You feel a pinch. Then, warmth spreads through your chest. Your shoulders drop. The pain is gone before your brain even finishes registering it happened. That's the promise fentanyl makes to a nervous system built by millions of years of evolution to fear pain above almost everything else. But the real story of what happens next is far stranger than relief. Your brain was never designed to meet a molecule like this. Deep inside your skull sit tiny docking stations called mu-opioid receptors. Neuroscientist Solomon Snyder first mapped these receptors in the 1970s, and what he found rewrote how we understand pain itself. Your body already makes its own natural painkillers, called endorphins, to unlock them. A hug, a finish line, a laugh with a friend. Small, gentle keys. Fentanyl is not a gentle key. It's a master key, roughly 50 times stronger than heroin and up to 100 times stronger than morphine, and it slams into those same receptors with overwhelming force. Here's where it gets strange. Those receptors aren't just in the areas that process pain. They sit in your brainstem, the ancient part of your brain that never asks permission to keep you breathing. Under normal conditions, that region fires on autopilot, sending the signal to inhale again and again, without you ever thinking about it. Fentanyl slows that signal down. Sometimes it stops it. Research from Dr. Nora Volkow at the National Institute on Drug Abuse has shown this respiratory depression is the reason fentanyl has become the leading driver of overdose deaths in the United States. Your brain simply forgets to tell your lungs what to do. But the story doesn't end at the brainstem. Fentanyl also floods a region called the nucleus accumbens with dopamine, the same chemical messenger tied to food, connection, and reward. Neuroscientist Candace Pert, who helped discover the opioid receptor itself, spent much of her career showing how tightly emotion and brain chemistry are woven together. That flood of dopamine is what your brain interprets as intense reward, not just relief from pain. Reward. Your brain starts treating survival itself as a bonus round, and your brain adapts fast. Within days, sometimes hours, those same receptors start shrinking back, becoming less sensitive. This is tolerance. It means the same dose that once brought that warm, floating calm barely registers at all. So the body asks for more, not out of weakness, out of biology doing exactly what it evolved to do: chase equilibrium. This is where the trap tightens, because your brain doesn't only crave the high anymore, it starts to need the drug just to feel normal. Take it away, and the nervous system swings hard in the opposite direction. Anxiety, aching, a body that forgot how to regulate itself without help. Scientists call this withdrawal, but really it's your brain violently trying to remember how it used to work before fentanyl rewired the wiring. Why does a molecule built in a lab hijack a system that took millions of years to build? Because evolution never had to prepare you for something 50 times stronger than the strongest natural signal it ever designed for. Your ancestors faced venomous bites, blunt injuries, childbirth. Pain was the warning system that kept them alive long enough to pass on their genes. Nothing in that slow, careful process could have predicted a synthetic key precise enough to override the exact lock meant to protect you. So when you hear that fentanyl is dangerous, even in doses smaller than a few grains of salt, that isn't an exaggeration. It's a direct consequence of how perfectly it fits into a lock your brain has carried since before humans could speak. Tonight, somewhere, someone's shoulders will drop after a pinch turns into warmth, and for a few short minutes, their oldest, most ancient alarm system will stay silent. The question is whether it ever learns to speak again.